Okay, I'm Blake Jones. I'm going to be recording and demonstrating this video of my circuit for FSE 100 Team 1 Eco Engineering Alliance for our autonomous robot system for lawn care. My robot was the Mow-Bot, which is basically a lawn mowing bot that can be semi-autonomously operated using a remote as well as its own inputs from a distance sensor. The configuration of this robot includes 3 DC motors, 2 of which are for powering the wheels, and 1 of which is for powering the blades. Additionally, there is a servo actuator that has that engages the blade on the front of the wheels, the distance sensor, which senses anything within its path, and the IR remote sensor. So to start this operation, quick review of the code here. So the idea of this robot is that it will be able to operate based off the inputs from this remote. So right here, with 1 being pressed, this robot will move forward. With 2 being pressed, it'll move right. 3 being pressed, it'll move backwards. 4 will turn it left. And then 5 is for the blades to turn on, 6 is for the blades to turn off, and then any of the other numeric buttons will be an all stop button for the vehicle as a whole. So all this vehicle is operating. It's additionally measuring the distance. Any distance that is less than or equal to 40 centimeters will cause the vehicle to stop, which will also make the blades stop. So to start operation, start the simulation here. So power on, serial monitor right now is reporting the distances. As you can see, the distance is out 58.4 centimeters, allowing the vehicle to operate currently. We'll go ahead and press 1. 1 will be moving the robot forward. You see both motors are operating at approximately the same RPM. Pressing 2 will cause this motor to reverse polarity and turning the vehicle to the right. Pressing button 3 will make the vehicle move in reverse with both in reverse polarity. Button 4 turning the vehicle left. So again, 1 moving the opposite direction of the other. And then button 5 turns the blades on. As you can see, this is the blade motor here, which also has the LED light that indicates the blades are operating. We also notice that the servo actuated 90 degrees to engage the front blades, which are operated off the same motor from a belt-driven system from the rear wheels. So now everything is operation. Put it back to 1. So this is as if the vehicle was moving forward at normal speed with the blades engaged. We want to turn the blades off. Press button 6, servo disengages, and the motor blade stops operating, but the vehicle is still able to move. Turning the blades back on, number 5, and everything's re-engaged. At this time, I'm going to test the distance sensor. So as I defined earlier, anything less than 40 centimeters would cause the vehicle to stop. So we'll adjust this down to below 40. And as you can see, all RPMs have moved to 0, blades disengaged on the front. Moving it back up to 40, the vehicle does not start again on its own. You have to reinitiate it as part of the safety protocol. And so now we are at an appropriate distance. The vehicle is reset, and we can restart the vehicle with button 1. It's now moving forward again. 2, turning to the right. 3, moving backwards. 4, turning to the left. And then we'll make it move forward again. Re-engage the blades. The blades are now operational. We want to turn the blades off. Blades turn off, LEDs off. Vehicle still moving, and then we can go ahead and check the distance again, and it all off. Moving the distance back up to where the vehicle is operational again, and we can continue this process. You see in the serial monitor window, it reports the distance continuously, and once we press a button, it reports that number, which inputs the values to allow these motors to engage. One other feature that I did not show yet, which I'll show real quick, is having all motors running, as well as the blades, proper distance. If you want to do an all stop of all vehicle, you press any of these other non-programmed buttons, 0, 7, 8, 9, and that will turn everything off the vehicle as an all stop. Thank you for watching, and I hope you enjoyed my presentation.